Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2022 Physics Paper 1 Higher Tier, question number 6 on the topic of electricity. Figure 8 shows how electricity is supplied to consumers by the national grid. Figure 8 is a diagram of the national grid. So you have the power station and transformer X, and then the overhead transmission cables and transformer Y and consumers. Now, explain why transformer X is used in the national grid. Now, just a little bit of note, the power stations generally produce electricity at about 25,000 or 25 kilovolts. Now, transformer X, it actually increases the voltage, so it's a step-up transformer. This is a step-up transformer, and it increases the voltage to about 400 kilovolts. And transformer Y is a step-down transformer, right? So for consumers, so for typical houses like us, it's about 230 volts. Now for office buildings, it might be slightly higher, but let's assume these are houses. So it's about 230 volts. Explain why transformer X is used in the national grid. Now, you need to understand it's about making sure that the power that is generated in the power station is transmitted to the consumers without losing too much of that power. So how would you do that? By trying to reduce the energy loss due to heating. Now, energy is lost in the wires due to heating because of resistance. In order to reduce the resistance, you'll have to reduce the current. Now, if you want to reduce the current, you'll have to increase the voltage. That way, you can or make sure that the power is actually conserved in a way. So this links to the equation P equals IV. So you want to reduce that, so that by increasing the voltage, you can actually increase the power. So the way you answer this question is, why is transformer X used? Transformer X increases the potential difference and decreases the current, reducing the thermal energy transfer to the surroundings or reducing thermal energy transfer from the transmission cables, so increasing the efficiency of power transmission. 6.2, explain why transformer Y is used in the national grid. Transformer Y is the step-down transformer. Now you got the voltage at 400 kilovolts or 400,000 volts. You need to reduce it to 230. Why? That is way too much voltage. So the simple answer is transformer Y decreases the potential difference to a safer value or level for consumer use. 6.3, the town of Hornsdale in Australia has electricity supplied by a huge battery. On one day, the battery transferred 3.24 times 10 to the power 11 joules of energy to the town. The potential difference of the town's electricity supply is 230 volts. Calculate the charge flow to the town on this day. So the charge, what they're asking is Q. The potential difference is V, and that's E for energy. So the equation that links all three of them is energy equals the charge multiplied by the potential difference. So substituting these values, 3.24 times 10 to the power 11 equals the charge multiplied by 230. So the charge Q is 3.24 times 10 to the power 11 divide that by 230. So let's see what the calculator tells us. 3.24 to the power of 11. Divide that by 230. Now, I'm going to write that number as it is because it's quite a long number and I don't really want to make any mistakes. So it's 1408 695 652 652. Now they want the answer in 3 significant figures, so I can write it in standard form. 1.41 times 10 to the power, so that's 3 6 oh 9, not 6. Let me change that. That's 9. So 1.41 times 10 to the power 9 coulombs. Now, just a little bit of notes about different types of transformers. So step-up transformer and step-down transformer, as you can see the difference, it is the main difference is the number of coils in the primary and the secondary coil. They're basically the opposite of each other. So what do step-up transformers and step-down transformers do? Step-up transformers increase the voltage, step-down decreases the voltage. And as you can read the rest of the information, it's important that you actually understand what the difference between these two different types of transformers are. That brings us to the end of this question. I will see you in the next question.